Welcome to Pod4 Journal Club. Today we're diving into something really cool, a paper that basically trains an AI to think like a medical detective. We're going to look at how a team of researchers built this model. They call it QuarkMedSearch, and explore what it might mean for the future of medicine. It's pretty wild stuff.
Okay, so let's start with a puzzle you've probably run into yourself. If you ask a standard AI assistant, something simple like, what are the symptoms of the flu, you'll get a perfect answer, right? But what happens when you throw it a real curveball, a complex, multi-step medical question that needs some real digging? Well, that's where they often just fall flat. So the big question is, why? And that question brings us right to the heart of the problem that these researchers are trying to solve. You could call it AI's medical blind spot. It's this inability to do deep, investigative work. See, just recalling facts isn't going to cut it when you're dealing with the incredible complexity of medicine. The best way to think about this is to compare a librarian to a detective. Your standard AI, it's like a fantastic librarian. It's amazing at fetching a book it already knows is on the shelf. It's just pulling from what it's already memorized. In the AI world, they call that its parametric memory. Right, so that's the knowledge the model has just kind of baked in. It can recall it directly without looking anything up. But when you're tackling a really tough medical mystery, a librarian just isn't enough. You need a detective. You need an AI that can do what the paper calls deep search. And that's a whole different ballgame. It's about actively investigating, connecting clues, and reasoning your way to an answer you didn't have at the start.
Okay, so how do you actually go about training a medical detective? If you want to turn that AI librarian into Sherlock Holmes, what's the game plan? Well, that's the exact question a research team at Alibaba's Qwen Applications Business Group set out to answer. And what they came up with is actually pretty brilliant. It turns out the secret isn't just building a bigger AI or throwing more data at the problem. Nope, the secret is a much better training plan. And their whole strategy started with building something they call a data factory. Now, this is the heart of their method, this 4-phase pipeline. I know it looks a little complicated on the screen, but just think of it as an assembly line for creating the perfect training course for an AI detective. It's designed to take simple medical facts and methodically turn them into these complex, twisty mysteries that the AI has to figure out completely from scratch. So let's break down how this factory actually works. First up, they generate some really tricky seed questions based on rare medical concepts. Then they send out a little AI agent to scour the web and ground those questions in real, up-to-date facts. Now, this next part is super clever. They actually hide or, obfuscate the key terms. This forces the AI to investigate instead of just recognizing a word. And finally, they check their work, using multiple AIs to make absolutely sure there's only one unique, correct answer to each mystery. What's so important here is that they're not just making data, they're building the detective school that teaches the AI how to think, not just remember.
All right, so with all this amazing training data ready to go, they put the model through a 2-stage AI boot camp. This is where the actual teaching happens, and it combines 2 pretty different learning techniques.
Okay, so stage 1 is called supervised fine-tuning, or SFT. The best way to think about this is like textbook learning. The AI gets shown a problem and the step-by-step solution, kind of like studying from an answer key. It's learning the basic rules of the road. But then comes stage 2, reinforcement learning, or RL. And this is like sending a rookie detective out on their first case. The AI has to try and solve problems on its own, and it gets rewarded when it finds the right answer efficiently. It learns from trial and error. So it's not just about being right, it's about getting smarter about how it finds the answer.
All right, so the moment of truth. After all that work, the custom-built data factory, the 2-stage AI bootcamp, the big question is, did it actually pay off? Let's take a look at the results.
And the answer was a resounding yes. Check out this quote from the paper. Their model, QuarkMedSearch, actually achieved state-of-the-art performance. It basically set a whole new standard for open-source models of a similar size.
This table really tells the story. So look at QuarkMedSearch. It's a 30 billion parameter model, and it hit a performance score of 55.71. That is a massive jump from its base model, which was down at 40.71. But here's the really wild part. Look at that GLM-5 model. It's a beast, 744 billion parameters, more than 20 times bigger. And yet, our little detective model is performing almost as well. That is seriously impressive.
But being a great detective isn't just about cracking the case, right? It's also about being efficient. And this is where it gets really interesting. That reinforcement learning part of the training didn't just make the model more accurate, it actually made it smarter about how it solved the problems.
And this chart shows you exactly what I mean. On the left, you see that before that reinforcement learning phase, the model needed, on average, about 28 tool calls. Think of those as search steps to crack a case. But after, that number dropped down to just 24. So it learned to solve the same tough problems, but with fewer steps. In the real world, that could mean faster answers for doctors and, frankly, it's cheaper to run.
Okay, but let's take a step back and get a dose of reality here. Good science isn't just about celebrating the wins. It's also about being super honest about the limitations. And to their credit, the authors were really upfront about what their model can't do, at least not yet.
So for one thing, this is definitely not a magic bullet for all of medicine. Its training and testing were focused primarily on Chinese medical scenarios. It also bumps up against a classic AI problem, context length. If an investigation gets too long and complicated, it can kind of lose the plot. And finally, they were really careful about what's called benchmark contamination, making sure the AI wasn't accidentally trained on the test questions, which would make the results look better than they are.
And they actually came up with a pretty simple, but honestly brilliant way to deal with that context length problem. When the AI gets tangled up in too many clues and goes down a rabbit hole? Well, they created a discard all strategy. If the AI's train of thought gets too messy, it just hits reset and starts the whole investigation over with a fresh perspective. And believe it or not, this simple trick worked wonders.
Okay, so we know the model works. It's a pretty good detective. But what can you actually do with it? This is where things get really exciting, moving from the lab into the real world. This is the part that shows why this research really matters.
So the team decided to put their new detective AI to a real-world test. Could its skills help with a practical task like generating a really comprehensive medical research report? To find out, they basically fused it together with another AI model, one that's a specialist at writing long, detailed documents.
And then they did the ultimate test. They handed these reports over to actual human medical experts for evaluation. The results, well, they speak for themselves. The new, smarter, fused model either won or tied in over 72% of the cases. That's a huge deal. It proves these detective skills aren't just for solving puzzles, they can be transferred to really useful, practical applications.
And that really is the big takeaway here. QuarkMedSearch is so much more than just one cool AI model. What this research really gives us is a recipe, a blueprint. It's a guide for creating highly specialized AI agents that can dive deep into complex problems in almost any field you can imagine, from law to finance to engineering.
Which brings us to one last big question to think about. Now look, we're not there tomorrow, but this research is a huge leap forward. It's a major step towards AI assistants that can be true partners for doctors, helping them investigate and crack the absolute toughest medical cases. Really, it's a glimpse into a future where AI could help make healthcare better, faster, and more accurate for all of us.